Assalamualaikum, my name is Siti Farzana binti Amir and my metric number is DE230132. Now I will present to you about the introduction. Induction motor derive their name from the induced voltage in the rotor winding. The motor's design impact its performance. Lowering the rotor conductor impedance improve efficiency at high speed, while higher impedance yield more torque at low speed. In the region past maximum torque, increasing the load on how low impedance motor does not reduce its speed. Instead, the torque continues to rise while staying steady, allowing the motor to maintain a constant speed regardless of load.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Fazliana Alia binti Abdul Rahman. My metric number is DE230128. I would like to explain about our methodology. Thevenin theorem is primarily used to simplify complex linear circuits, especially those involving the induction motor. This theorem is particularly useful for analyzing power systems. Thevenin theorem has been used considering that it is an appropriate technique for induction motor. In order to compute the torque speed and power speed characteristic, this method is utilized to equate the voltage source and the impedance. An equivalent circuit made up of the one voltage source connected in series with one resistance can be used in place of the voltage source and resistance. This is our flowchart. It shows the process of analyzing and calculating characteristics of torque speed and power speed.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Alia Tasha binti Yusran. My metric number is DE230125. Okay, I will explain about the workflow. Firstly, selecting a value for each parameter. D is to identify the proper value for each of the induction motor, including the speed, torque, efficiency, power factor, and so on. Next, the value need to be calculated in the following step. To determine the corresponding motor properties, some calculations are made based on the selected parameter value. After that, insert value for each characteristic as specific in the instruction. A graph is plotted according the instruction of each part of the induction motor. For step, the user follow with the instruction by the workflow to examine each graph of the characteristic. To learn more about the behavior and function of the motor, the per graph analysis. The final, prepare the newsletter and giving a project presentation. Next, I will explain about description. D is the parameter that we use in this project. The motor has a rated voltage of 415 volt and 4 poles. The rated power of the motor is 20 HP. The stator resistance is 0.3 ohms and the stator reactance is 0.7 ohm. The rotor resistance is 0.5 ohm and the rotor reactance is 1 ohm. The magnetizing reactance is 15 ohms. The mechanical losses are 2000 watt. The core losses are 500 watt. The miscellaneous losses are 0.25 watt. And the last one is the slip value is 0.1555. This phase induction motor has a relative low stator and rotor resistance, indicating the low losses and high efficiency. Goal in this project, we want to find the torque speed characteristic and also the power speed characteristic. Okay, three-phase induction motor are widely used in a variety of industry and commercial application due to their reliability, efficiency, and ease of operation. This is some of the common applications where three-phase induction motor are typically used. Firstly, in industrial application, which is compressor, resident application, washing machine and dishwasher, renewable energy application such as hydroelectric power and wind turbine. That's all for me. Thank you.
Hello, my name is Nur Akila binti Murad. I want to explain about the graph. Graph from result 1 shows the plot of torque speed characteristic of the induction motor. Excel software was used as a platform to perform simulation for this project. This simulation was made with the chosen parameter and design table in the Excel software. According to the theory of top speed characteristic, we will get n ascending and descending graph, but we only get 20% of the top speed graph theory because we only take 10 slip value to build the graph. The value of slip we chosen for the top speed characteristic is 0.0155. The first slip value is set to 0.0155 instead of 10. This decision was made because we must avoid divide by zero problem. Next, to get the top speed characteristic mentioned, the formula of rotor torque index in the table for the simulation in Excel. For result 1, the graph shows the value of static torque when using the selected parameter that has been mentioned. As we can see, we did not get the pull-out torque because we only take 10 value of slip. If the slip value increase, then the motor speed value decrease. If the slip value increase, then the inductor torque value increase. Lastly, if the value of torque inductor increase, then the value of speed motor decrease. Graph for result to show the plot of power speed characteristic of the induction motor. To get this result, the same process to get the simulation in Excel as the flow in result 1 was used, and we need to mention the value of slip of the power speed characteristic between 0 and 1 as usual. Also need to put the formula for rotor torque inductor and the formula for output power for the table in Excel to get the torque speed characteristic. In result 2, it shown the maximum value of the output power and mechanical speed when using the selected parameter or variable than we already given. From the graph, the value increased proportionally to the maximum output power and mechanical speed at 35341.20331 watt and the 1176.175 pm. If the slip value increased, then the motor speed value decreased. If the slip value increased, then the power convert value increased. Lastly, if the value of power converted increased, then the value of speed motor decreased. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Zahira Nadia binti Zaini and my metric number is DE230110. Now I will present about the manual calculation. For the question is, the following parameters are given to represent a 15 Hz Y connected 3-phase induction motor. This is our parameter variable that we have choose. So next is Thevenin equivalent. This is our circuit for Thevenin. Next is I will talk about the R2 multiply 1 minus S divide S is we can get the answer is 31.76 ohm. Next is we need to make the circuit is the simple circuit, so we need to find the Z2 is which is a series of JX2 plus R2 plus R2 multiply 1 minus S divide S. So we can get the answer is 32.26 plus J1 ohm. Next is we need to find the ZF, which is JSM parallel with Z2. So we can get the answer is 5.59 plus J12.224 ohm. Next, we need to find the Z total, which is series. So we need to multiply R1 plus JX1 plus ZF. So we get the answer is 5.89 plus J12.424. Next, we need to find the V pace. The formula of V pace is rate HP divide square root 3 equal to 415 divide square root 3. So we get the value of V pace is 216. Next, we need to find IL equal to IA equal to V pace divide ZT. So we get the value of IL equal to IA is 7.6 minus J 16.65. So next we need to find the P in. The formula of P in is 3V base IA cos theta. So we get the value of P in is 59211. Next, we need to find the PSCL. The formula of PSCL is 3 multiply IA squared multiply R1. So we get the answer for the PSCL is 301.73 watt. Next, we need to find the power air gap. The formula of power air gap is 3IA squared multiply RF. So the value of power air gap is 5622 watt. Next, we need to find the P convert. So the formula of P convert is 1 minus slip multiply power air gap. So we get the value of power convert is 5534.86 watt. Next, we need to find the P out. The formula of P out is refer to the power line. So the formula of P out is P convert minus P max minus P call loss minus P miss. So we get the value of P out is 3034.61 watt. Next, we need to find the N since the formula of N synchronous is 120 multiply frequency divide pole. So we get the value of N since is 1500 rate mid. So next we need to find the W since. The formula of W since is N since multiply 1 minute divide 16 second multiply 2 pi rate divide 1 rate. So we get the value of W sin is 157 rate second. Next, we need to find the torque induced. The formula of torque induced is power air gap divide W since. So we get the value of torque induced is 35.74 Newton meter. Next, we need to find the Nm. The formula of Nm equal to 1 minus slip multiply N since. So the value of Nm is 1476.75. Next, we need to find the Wm. The formula of Wm is 1 minus slip multiply W since. So the value of Wm is 154.645 rates. Next, we need to calculate the efficiency for the whole value is the formula of efficiency is P out divide P in multiply 100. So we get the value of efficiency is 51.25%. Thank you from me.
Now I will present to you about the conclusion. The key findings from the torque motor speed graph are: first, there are a direct linear relationship between motor speed and torque output. As speed increases, torque increases proportionally. Second, this indicates the motor ability to generate higher torque at higher speed. Third, the consistent relationship between power conversion and motor speed suggests a direct link between motor's power output and its rotational speed. Higher speed corresponds to higher power conversion. In summary, the graph reveals a linear correlation between motor speed, torque, and power, highlighting the motor performance capabilities across these unrelated parameters.